Okay, so today we discuss method of variable and separable. Variable and separable method. So this is the first method of solution of differential equations. Solution of first order and first degree differential equations. Okay. So in previous class, I explained a few questions related to 12th class NCERT. Before that, I explained concept. What is the meaning of variable and separable, and how to separate the variables, and after that, how to integrate that. Okay. So now it is purely completely for engineering and degree students. So related to that, I will discuss few more questions in this topic. So if you want more questions, just see the previous topic also. So previous topic means where I explained method of variable and separable related to 12th NCERT. So if you revise that, if you have to revise those questions, then you will be getting more ideas. Okay. So mainly, what is the meaning of variable and separable? Suppose the derivative is dy by dx. Now we separate the y term and x term, or separate x term and y term. After that, we can integrate. And we know very well about all the integrating formulas, integration formulas, integral formulas. That is, formula depends on the given question. Okay. Now see this question. So this is the actual equation here. What is that? Dy by dx plus square root of 1 plus y square by 1 plus x square equal to 0. Right? Now I am writing that equation. Given that dy by dx plus square root of 1 plus y square by 1 plus x square equal to 0. Now actually this is the form of root of a by b. Root of a by b can be written as root a by root b. Then how to write this value? It is same, don't change this. Clear? And here if you want, just write that side. So minus square root of 1 plus y square by 1 plus x square. Now separate both numerator and denominator, that is minus root of 1 plus y square by 1 plus x square. Clear? And then dy, here it is in numerator and dx is in denominator. So that denominator dx value we can write that side. And here y term is there. That y term we can write this side. If you take this y term in this side, in left hand side, it will comes to denominator. In that case, how to write that value? Dy by root of 1 plus y square. So here minus dx by root of 1 plus x square. And again this can be written as dy by root of 1 plus x square plus dx by root of 1 plus x square equal to 0. This is actual process. But what I am suggesting, these two steps are not required. Directly, here numerator value is root of 1 plus y square. Take that term here in denominator. And take this value for here in numerator. Then both are separated. That is the meaning of this one. Otherwise, if you want step by step clearly, you can write it. Now we separate both x and y terms, right? X term is separated, y term is separated. After this, integrating on both sides, IOB. But I am writing the x term first. Integral dx by root of 1 plus x square plus integral dy by square root of 1 plus y square equal to 0. And this is one standard formula. What is that formula? So integral dx by root of a square plus x square. How to write it? Log of mod of x plus root of a square plus x square plus constant. Okay, by using that formula, how to write first one? Log of mod of x plus root of a square plus x square means same value, and coming to second one, log of mod of y plus square root of 1 plus y square equal to c is constant, log c is also constant. This is one value. Got it, my point? Or one more formula is also there. Same value can be written as sin h inverse of x by a. Clear? If you want to use this formula, here a value is equal to 1, here a value is equal to 1. Then write sin h inverse of x by a means a equal to 1. and second value sin h inverse y equal to constant. So either this one or this one, which is the required general solution of the given equation. Now this is second question. What is the given equation? dy by dx equal to e power x plus y plus x square into e power y, right? And we know that e power a plus b equal to e power a into e power b. So this can be written as e power x into e power y, x square into e power y. Now e power y is common, we get e power x plus x square, right? And how to write this? If you write e power y this side, will get in denominator, right? And if you write dx that side, same term will get in numerator. Means we separated both x and y terms. Now integrating on both sides. Then it is integral e power minus y dy. And here integral of e power x plus x square into dx. Now how to write it? Integral e power x dx plus integral x square into dx, right? And what is the formula of e power ax dx? Means integral value. Okay, now again here it is same integral e power minus y dy, and this is the standard formula. Integral e power ax dx equal to e power ax by a. Similarly, integral x power n dx equal to x power n plus 1 by n plus 1. These are the standard formulas, right? So how to write it? Here a equal to 1. So e power minus y by minus 1. And coming to this e power x, and it is x power 2 plus 1 by 2 plus 1. Then constant, see. So this is minus e power minus y. Then here e power x plus x cube divided by 3 plus constant, see. Or if you want one more step, minus e power minus y minus e power x minus x cube by 3 equal to 6. And here minus is common. What is the remaining? E power x plus e power minus y plus x cube by 3 equal to constant. Now multiply with the minus. Then how much we get here? E power x, e power minus y, x cube by 3 equal to minus c, that equal to k. Where k equal to what is that? Minus c. So minus c constant to k is also constant. Then because of that reason we represented by k. So this is the final solution. Required general solution. Now question number 3. dy by dx equal to e power x minus y plus x square into e power minus y. Same as previous question only. What is the given value? dy by dx equal to e power x minus y x square into e power minus y. And e power x minus y can be written as e power x into e power minus y and x square into e power minus y. So e power a minus b equal to e power a into e power minus b. Clear? In this e power minus y is common. Then what is the remaining? E power x plus x square. And how to write it? dy by e power minus y, e power x plus x square into dx. Now integrating on both sides. Now this can be written as integral e power y dy and integral of e power x plus x square into dx. And again integral e power y dy, and here integral e power x dx plus integral x square dx. Now this is standard formula. Integral e power ax dx equal to e power ax by a. Similarly, integral x power n dx can be written as x power n plus 1 by n plus 1. These are the standard formulas, okay? And here a value is 1, so it is e power y, and it is e power x, x power 2 plus 1 by 2 plus 1, then constant, see. So how to write it? E power y. If you write e power x this side, we get minus e power x, and here it is x cube by 3. If you write this side, minus x power 3 by 3 equal to constant. That is the required solution. This is the fourth question. To solve 3 into e power x into tan y into dx plus 1 minus e power x into secant square y into dy equal to 0. So what we did in first question, here also we are applying same. Simple shortcut way is there, we use that one only. So it is 1 minus e power x, then secant square y into dy equal to 0. Do one thing, write 3 into e power x. Then here dx, 1 minus e power x term take here. Then we will get in denominator, x term is over. And what is the y term here? Secant square y dy. And one more y term is there, take that side. That side, I mean for second term. Then we'll get in denominator equal to 0. Now both are separated, then integrating on both sides. Then 3 into integral e power x by 1 minus e power x dx. Second one, integral secant square y into dy by, what is that? Tan y equal to 0. Now substitution method. 1 minus e power x equal to t. Derivative of 1, 0. Derivative of e power x, then dx equal to dt. So from this we get e power x dx equal to minus dt. And the second one, tan y equal to p. Derivative of tan is secant square, secant square y into dy equal to dp. So how to write this one? 3 e power x dx means minus dt divided by t plus secant square y dy, that is dp, by p equal to 0. And what is integral dx by x? This can be written as log x or log of a mod of x. Okay. So it is minus, then minus 3 log of t, right? And here log of p. Both are logarithmic functions, then write log c. And again this is the form of m log a. So m log a can be written as log a power m. If you want that formula, just write here m log a equal to log a power m, right? So then log a means t, m is minus 3, and then log p equal to log c. Again this is the form of log a plus log b. What is the value of log a plus log b? Log of ab. So log of ab means log of what is a? T power minus 3, and it is p. Then it is log c. Now log cancel. Then how to write this? P by t cube, right? Equal to c. Our same value can be written as p equal to c into t cube. But what is the value of p? P value is tan y. So this can be written as tan y, and here c, and coming to t, 1 minus e power x. T cube means whole cube. So which is the required general solution? This is fifth question. What is the given value here? Y minus x dy by dx equal to a into y square plus dy by dx, right? Now first term is ay square, second term is a into dy by dx, and here it is y minus x dy by dx. Do one thing. This x dy by dx write that side, and ay square write this side. Then y minus ay square equal to a dy by dx. If you write negative term that side, we get positive value, and in this, which is the common value? Dy by dx is the common value. So a plus x, and it is y minus ay square. But actually derivative dy is in numerator. Better take this term that side, and here it is in denominator. Take this term this side. Okay. If you take this term this side, we'll get dx by a plus x, right? This is the first term. I mean one side value. And if you take this value that side, we get dy by y minus ay square. Now integrating on both sides. That is integral dx by what is that? A plus x. And integral dy by y into 1 minus ay. Okay. Now this is equation number 1. And here it is product of two terms, that product of linear factors. Now we use partial fraction method. So we'll take that. What is that value? 1 by y into 1 minus ay. So this can be written as a by y, okay, and b by 1 minus ay, equation number 2. And again it is same, 1 by y into 1 minus ay, and here LCM is y into 1 minus ay, right? And a into 1 minus ay plus b into y. Now both are gets cancelled. Then what is the remaining value? 1 equal to a into 1 minus ay plus b into y. Now what is the substitution? So here y equal to 0, na? And 1 minus ay equal to 0 means 1 equal to ay, y equal to 1 by a. So substitution, y equal to 0 and y equal to 1 by a. Clear? I am writing here. So first substitute y equal to 0. If y equal to 0, it is same, that is 1 only. And coming to this, a into 1 minus 0, na? Why? Because a into 0 is 0 plus b into y, b into 0, and it is a. Now what is the value of a? A equal to 1. So it's clear, right? And again we substitute y equal to 1 by a. So again it is 1 only. And if you take this a into 1 by a gets cancelled, we get 1 minus 1. If you want, just write here a into 1 minus a into 1 by a and b into 1 by a. Clear? Now both are gets cancelled. Now 1 minus 1 0, na? A into 1 minus 1 plus b by a. So here it is 0. Then we get b by a. Already LHS value is 1. Now what is the value of b? 1 into a equal to a. And now substitute these two values in this equation. I mean equation number 2. So 1 by y into 1 minus ay equal to, so a by y, what is a? A is equal to 1, right? So 1 by y plus b value is a, divide by 1 minus ay. Clear? Now substitute in equation number 1. Then write here from equation number 1, what is left hand side value? Dx by a plus x, right? And here integral of 1 by y, a by 1 minus ay into dy. So this is the standard formula, na? What is that? Integral dx by a plus x equal to log of a plus x, or log of mod of a plus x, okay? And second formula, integral dx by x, how much it is? Log of x. Third formula, integral dx by ax plus b, that is 1 by a log of ax plus b. If you want, you can use modulus also, okay? Now this is direct formula, na? What is that? Log of ax, a plus x, right? Now see, that first formula, na? Integral dx by a plus x means what is that? Log of a plus x. Otherwise, if you want to write log of mod of a plus x, you can use that one also, okay? And the integral dx by x, that is log x, where x equal to y. And coming to this a constant, then 1 by a means here y coefficient is minus 1, minus a, minus 1, again a is that, minus 1 into a is minus a. Then log of, what is that? Same term, 1 minus ay. Now a gets cancelled. Then write here all are logarithmic functions, na? Then write log c. Now see, again it is what is that? Log of a plus x. And coming to this one, log y minus log of 1 minus ay plus log c. Clear? Log a minus log b. What is that? Log of a by b means log of y by 1 minus ay. Then plus log c. Again log a plus log b, that is log of ab. So log of a means what is that? C, or y by 1 minus ay also, no problem. Why? Because that is only product, na? If you write c into y by 1 minus ay or y by 1 minus ay into c, value cannot be changed. And here it is log of, what is that? A plus x. Now both sides logarithm gets cancelled, na? Then what is the remaining value? If you want to write 1 minus ay this side, just write a plus x into 1 minus ay equal to c into y. So that is the required general solution. Now this is question number 6. Find the equation of the curve passing through the point 1, 1 whose differential equation is y minus yx into dx plus x plus xy into dy equal to 0. This is also method of variable and separable only. Okay. So first we write the given equation. Given that y minus yx into dx and x plus xy into dy equal to 0. So here y is common. What is the remaining? 1 minus x and x is common. Then 1 plus y into dy equal to 0. Better derivative dy is here, dx is here. Now write x here, y there. If you write x here, then how to write that? 1 minus x by x into dx. And here 1 plus y by y into dy equal to 0. Now integrating on both sides. Now what is that first term? 1 by x. Then minus x by x, right? Dx. Actually it is not required. X by x means 1. If you want you can write it, otherwise you write direct value. Okay. And this side, first one is 1 by y dy. Second one, y by y dy equal to 0. So this is direct formula na log x. X cancel remaining integral dx. That is x only. And again it is log y. Then plus y plus constant to c. If you want, just write here integral dx by x equal to log x and integral dx equal to x. These are the formulas. Then if you want one more step, just write log y this side minus x that side. It is not required. If you want, you can write it. But what I am doing, just directly I am taking this equation. And here, this is a general solution. But this whole equation passing through the point 1 comma 1, by putting x equal to 1, y equal to 1, we get arbitrary constant c value, and again we have to substitute c value in this place, then we get required particular solution. Okay, now equation 1 passing through the point. What is that point 1 comma 1? So how to write it? It is log 1 minus 1, again log 1 plus c. But what is the value of log 1? It is equal to 0. So left hand side value is 0 minus 1. It is 0 plus 1 plus constant. 0 plus 1 is 1. And here it is minus 1. In next step, write plus 1 this side. Why? Because we want c value. Therefore, c equal to minus 1 equal to minus 2. Clear? Now, substitute c value in equation number 1. Again, from equation number 1, log x minus x, and here log y plus y, and plus c. C is minus 2. Plus into minus, minus. So, minus 2. So, this is the required particular solution of the given differential equation. Clear? This is 7th one. Solve dy by dx equal to sin x plus x into cos x divided by y into 2 log y plus 1. So this is also same method, variable or separable only, right? So this is a little bit lengthy question, but simple question, easy question. So given that dy by dx equal to sin x plus x into cos x, and coming to denominator y into 2 log y plus 1. Now cross multiplication. What is that? Sin x plus x into cos x into dx. And here y into 2 log y plus 1 into dy. So what is the first term? After this, do one thing. Directly integrate on both sides, okay? Then integral sin x dx. Second one, integral x into cos x into dx. And here, two constant, integral y into log y into dy. Again y into 1 is y. That is integral y into dy. And we know very well about this formula. Integral sin x dx equal to minus cos x. So this is direct formula. And coming to this, that integrating by parts. So I am writing here. First term is there now. What is that? X. That is u. U equal to x. Du equal to dx. And the second one is there now. That is dv. What is the value of v? Integral cos x dx. Okay. Then how to write this one? Integral cos x dx can be written as sin x. Na? Clear? Now this is the formula. Integral u dv equal to uv minus integral v du. Okay. If you want, just write here dx also, no problem. dv equal to cos x dx. Means this is your remaining whole value is equal to dv. What is my point? Now plus, what is that first term? uv, na? U means x. V means sin x. Minus integral, again v du. Again v means sin x. Du means dx. This is LHS value. And coming to right hand side, again same method, integrating by parts only. But here u equal to log y and du equal to 1 by y into dy. And the remaining value is there now. What is that? Y dy. So that is dv. So dv equal to y into dy and v equal to integral y dy. That can be written as y square by 2. Again use same formula. So u means log y, right? Into v means y square by 2 minus integral v du. Again v means y square by 2, du means 1 by y dy. Then plus integral y dy can be written as y square by 2, na? Like x power n plus 1 by n plus 1 formula. And here how much it is? Minus cos x. Okay. And x sin x minus, what is integral sin x dx? Minus cos x. Clear? And coming to this side, 2 into y square by 2 log y and minus 1 by 2 is constant, right? 1 y cancelled. What is the remaining? Integral y dy. Again if we integrate y, then we get y square by 2. Okay, so this one is over. And here plus y square by 2. Now add arbitrary constant c. Okay, now how to write it? Minus cos x, then x into sin x, and minus of minus plus cos x. Now both are gets cancelled, right? And the 2 cancelled, that is y square log y. And one value cancel, this 2, this 2. What is the remaining? Y square by 2, na? Again plus y square by 2, then constant. See, both are gets cancelled, right? What is the remaining value? So here x into sin x. Okay. If you write y square log y this side, we get minus y square into log y, na? And what is the remaining value? C. So this is the required general solution. And this is called integrating by parts. Okay. ఏదమ్మా see, now this is 8th question. Solve dy by dx plus y square plus y plus 1 divided by x square plus x plus 1 equal to 0. So it's also very simple. What is the given equation? Dy by dx plus y square plus y plus 1 divided by x square plus x plus 1 equal to 0. Do one thing, write this whole y term this side. Means we will get in denominator here y square plus y plus 1. And this can be written as dx by x square plus x plus 1 equal to 0. Both are separated, na? Then integrating on both sides. So integral dx by x square plus x plus 1 and integral dy by y square plus y plus 1 equal to 0. First I wrote x term, then I wrote y term. Okay, but there is no direct formula for this. This is one type of quadratic polynomial. So just I'll explain only this one. If you are perfect with this, means if you know this one, then it is easy, na? Now I am taking this value. So what is that? X square plus x plus 1. Now see here, middle term is positive, na? Then reduce into a plus b whole square form. Convert into a plus b whole square formula. What is the expansion of a square? A plus b whole square. A square plus 2ab plus b square. Right? That this is the first term a square. So a square 2ab. 2 into what is a x? If you write 1 by 2, 2 gets cancelled, right? What is the remaining? X equal to this one. 2ab. B is 1 by 2. Next term is b square. That is 1 by 2 whole square. But 1 by 2 whole square means 1 by 4 is not in this term, na? Then immediately write minus 1 by 2 whole square. Then given constant to 1. So how to write this one? A plus b whole square. A is x. D is 1 by 2 whole square. And what is the remaining value here? 1 minus 1 by 4. Again x plus 1 by 2 whole square. 4 minus 1, 3. So 3 by 4. Na? Then x plus 1 by 2 whole square. And that can be written as root 3 by 2 whole power 2. Now, how to write this? Integral dx by x plus 1 by 2 whole square plus root 3 by 2 whole square, right? And here also same, only variable is the different, right? And based on this, by using this, how to write this one? Y plus 1 by 2 whole square plus root 3 by 2 whole square. Clear? And which form it is? Integral dx by a square plus x square or x square plus a square. That is 1 by a tan inverse of x by a. So 1 by a, what is the value of a? Root 3 by 2. Tan inverse of x by a. X means x plus 1 by 2, right? A means root 3 by 2. Again same formula, 1 by a, 1 by root 3 by 2. Then tan inverse of here y plus 1 by 2 divided by root 3 by 2. Then constant to c. So this is separate value. Okay. Now 1 by root 3 by 2 can be written as 2 by root 3. Na? Actually this is the common value in these two, right? Now take out. Then what is the value here? Tan inverse of, if you take LCM for this numerator, that is 2. So here 2x plus 1. And if you write root 3 by 2 in numerator, we get 2 by root 3. So this is the first term. And again here, how to write that value? So for this equal to 0, for this also equal to 0, do one thing. Right here equal to C. Okay. But because this is equation, then we write 0, 0. And then plus tan inverse, I mean second one. How to write it? LCM is 2 na. So 2 into y, 2y plus 1 into 2 by root 3 equal to C. Now this 2, this 2, this 2, this 2 cancel, right? Now here bracket closed na. In next step, write 2 by 3 that side. And here what's the remaining value? Tan inverse of 2x plus 1 by root 3 plus tan inverse of 2y plus 1 by root 3. And if you write the 2 by root 3 that side, then we get C by 2 by root 3. Na? And it is constant. It is also constant. Constant by constant is also equal to one more constant C. So this is the required general solution. This is question number 9. Solve dy by dx minus x into tan of y minus x equal to 1. How to write this? Dy by dx x into tan of y minus x is equal to 1. Now substitution method, the bracket value is there na, y minus x, that is equal to t. Now differentiating with respect to x. So it is dy by dx minus 1. It is dt by dx. From this we get dy by dx equal to dt by dx plus 1. And now substitute in this. What is the value of dy by dx? That is dt by dx plus 1 minus x, then tan of y minus x is t, again equal to 1. Cancel do one thing, and x tan t is there na, right that side, so equal to x into tan t. And how to write this? dt by tan t. Clear? Here x into dx. Now I will be done. And 1 by tan can be written as cot to t, right? dt. And it is integral x dx. What is integral cot x dx? That can be written as log of sin x or log of mod of sin x. Okay. And this is integral x power n dx formula. How much it is? X power n plus 1 by n plus 1. So here it is log of, what is that, sin t na? And that side x power 1 plus 1 by 1 plus 1, then constant to c. And this can be written as log of sin of, what is the value of t? Y minus x, right? And coming to this one, x square by 2 plus constant to c. If you want one more step, just write x square by 2 this side, then we get minus x square by 2. Now this is question number 10. What is the given value here? dy by dx equal to 4x plus y plus 1 whole square. Given that dy by dx equal to 4x plus y plus 1 whole square. Again this bracket value is equal to t. 4x plus y plus 1 equal to t. Now differentiating with respect to x. So it is 4 into 1 dy by dx plus 0, and it is dt by dx. Now dy by dx equal to dt by dx minus 4. Then how to write this equation? Dy by dx means that is dt by dx minus 4. And this whole value is equal to t square. Now write minus 4 that side, we get plus 4, that is t square plus 4. Now variable and separable method, that is dt by t square plus 4 equal to dx. Now integrating on both sides. How to write it? Integral dt by t square plus 2 square, right? And integral dx. And what is the value of integral dx by x square plus a square, or a square plus x square, that is 1 by a tan inverse of x by a. And by using that formula, how to write it? 1 by 2 tan inverse of x means t, a means 2, and integral dx means x plus constant 2. So 1 by 2 tan inverse of what is t? 4x plus y plus 1 divided by 2 equal to x plus constant. That is the final answer. I mean required general solution. Now this is question number 11. Solve x plus y whole square into dy by dx equal to a square. This is the given value, right? And now x plus y equal to t, differentiating with respect to x. So it is 1. It is dy by dx and here dt by dx. Now what is the value of dy by dx? That can be written as dt by dx minus 1. So how to write this value? So it is t square. Dy by dx means dt by dx minus 1. That's right, a square. So t square into dt by dx minus t square equal to a square. Next step, write minus d square that side, okay? And here we get t square into dt by dx and a square plus t square. Clear? And now, how to write this one? T square by a square plus t square into dt equal to dx. Separated both the terms. So all t terms one side, remaining x term on other side. Okay. Now integrating on both sides. But we can't integrate this, right? So what I am doing here, actual denominator value is a square plus t square. We want same form in numerator, but actually it is only t square. For that, just add and subtract a square in numerator. Okay, so a square minus a square cancel, remaining is t square. And the denominator value is what is that? A square plus t square into dt. And here integral dx. Now split these terms. What is that first term? Integral of a square plus t square by a square plus t square dt, right? And minus a square divided by a square plus t square into dt, and it is x. Now both are gets cancelled. What is the remaining value? Integral dt. Integral dx is x. Similarly, it is t. Clear? And here a square constant. And the remaining is same form. I mean integral dx by a square plus x square. How much it is? 1 by a tan inverse of x by a. So minus a square into 1 by a tan inverse of x means t by a equal to x plus constant c. So 1a gets cancelled. Now finally substitute t value. What is the value of t? X plus y. So how to write it? I am writing here. That implies x plus y, and here minus a tan inverse of t by a means what is the value of t? X plus y divided by a equal to x plus constant. Now x gets cancelled. Then what is the remaining value? So y minus a into tan inverse of x plus y divided by a equal to arbitrary constant c. So which is the required general solution of the given differential equation. So this is the next question. Solve x square plus 1 into y1 plus y square plus 1 equal to 0, y of 0 equal to 1. y1 means first order derivative dy by dx. Okay, so how to write this value? Given that x square plus 1 into y1 y square plus 1 equal to 0, and this can be written as x square plus 1 into dy by dx, right? And here y square plus 1 equal to 0. Now how to write this? Dy by y square plus 1, and it is dx by x square plus 1 equal to 0. Direct step now. Dy derivative is in numerator. Take this term here. We'll get in denominator. Actually, it is in denominator derivative dx. If we interchange these two terms, I mean if you write this whole value here, both numerator and denominator can be interchanged. Then we get dx by x square plus 1. Now direct formula, this one, right? Integrating on both sides. So first I am writing the x term, dx by x square plus 1. Second one dy by y square plus 1 equal to 0. And this is the formula, na? Integral dx by x square plus a square equal to 1 by a tan inverse of x by a. Clear? And what is the value of a here? 1. So this can be written as tan inverse x. And that can be written as tan inverse y. Actually c, but that also can be written as tan inverse c. And this is direct formula. Tan inverse x plus tan inverse y. What is the value of that? Tan inverse of x plus y by 1 minus xy. And here tan inverse c. Both are gets cancelled, na? So because of this reason, we got tan inverse of c here. Okay. Now what is the required value? X plus y by 1 minus xy equal to c, or x plus y equal to c into 1 minus xy. So that is the required general solution. Now say this is question number 13. Cos theta dr minus r into sin theta d theta equal to 0. What is the given equation? Cos theta dr r into sin theta d theta equal to 0. Do one thing. Take r here, means dr by r, minus sin theta. Take cos that side. I mean for second term. We'll get in denominator into d theta equal to 0. Now integrating on both sides, na? So it is integral dr by r. Integral sin by cos is tan theta. Then d theta equal to 0. Now what is integral dx by x? Log x, or log of mod of x. Okay. And integral dx, tan x dx, log of secant x, na? Or log of mod of secant x. Clear? Then how to write it? It is log r minus log of secant theta. Otherwise, if you want to use that modulus, you can use this. And here both are logarithmic functions, na? Then we write log of c or log of mod of c. Okay. And this is the form of log a minus log b. Log a minus log b can be written as log of a by b. And by using that formula, how to write it? Log of mod of r divided by mod of secant theta, na? And here log of mod of c. Cancel. And this whole value can be written as mod of r by secant theta equal to mod of c. Then r by secant theta equal to c, or r equal to c into secant theta. Or the same value can be written as like this also. 1 by secant means cos. So r into cos theta equal to c also. So either this one or this one or this one. If it is MCQ, then that is depends on the given options. This is question number 14. Solve sin inverse x into dy minus y into dx by root of 1 minus x square equal to 0. What is the given term? Sin inverse x into dy. So y into dx by root of 1 minus x square equal to 0. I'll do one thing, write y here. That is dy by y minus dx by, so it will comes to denominator, na? Sin inverse x into root of 1 minus x square equal to 0. Now integrating on both sides. So integral dy by y, integral dx by, what is that term? Sin inverse x into root of 1 minus x square equal to 0. Now this is standard formula, na? What is that formula? Integral dx by x. How much it is? Log x, or log of mod of x. So similarly, it is log y. If you want, you can use some mod also, no problem. And for this substitution method, what is that? Sin inverse x equal to t. Derivative of sin inverse x is 1 by root of 1 minus x square. dx equal to dt. So minus integral. So dx by root of 1 minus x square is dt by t equal to 0. So it is log of mod of y, and the same formula na mod of t. Both are logarithmic functions na, then write here log of mod of c. Again log a minus log b, log of a by b, that is mod of y by mod of t, and here log of mod of c. Clear? Cancel that. Then how to write it? Mod of y by t mod of c. So that implies y by t equal to c, or same value can be written as y equal to c into t. Therefore y equal to c into what is the value of t? Sin inverse x. So this is the required general solution. Now this is the last question, that is question number 15. Find the equation of the curve passing through the point 0, minus 1, and whose differential equation is 1 plus y square into dx plus 1 plus x square into dy equal to 0. So first we write given differential equation. What is that? 1 plus y square into dx plus 1 plus x square into dy equal to 0. Now how to write it? Dx by 1 plus x square, right? Plus dy by 1 plus y square equal to 0. Correct? We separated both x and y terms. Okay. Now integrating on both sides. Then integral dx by 1 plus x square. And here integral dy by 1 plus y square equal to 0. And this is standard formula. Integral dx by, what is that? A square plus x square. So 1 by a tan inverse of x by a. Right? Here a is 1. Here also a is 1. Then how to write it? Tan inverse x. Second term of tan inverse y. And right hand side again we'll take tan inverse. And this is a direct formula. Tan inverse of x plus y by 1 minus xy equal to tan inverse of c. Cancel that. What is the remaining value? X plus y by 1 minus xy equal to c. And this can be written as x plus y equal to c into 1 minus xy. So equation number 1. And this equation passing through the point 0, minus 1. So equation 1 passing through the point, what is that? 0, minus 1. That is x equal to 0, y equal to minus 1. Then how to write it? Therefore x is 0, y is minus 1, c into 1 minus, it is 0 na? So equal to c. Now what is the value of c? c equal to minus 1. Plus or minus minus. 0 minus 1 is minus 1. Okay. Now we substitute the c value in this equation. So I am writing here 1 implies that, what is that? X plus y na? Equal to c means minus 1 into 1 minus xy. So how to write it? Minus 1 plus xy. So that can be written as xy minus 1. If you want one more step, just write x plus y minus xy plus 1 equal to 0. So that is the required particular solution. Why? Because it does not having arbitrary constants. See, by using this initial condition, so we found that c value. If it contains c, that is called the general. But without arbitrary constant means a particular solution.